Hello. Uh, so join me. I am live now. Uh, Today we are going to talk about again another part of C programming, and that is recursive. So what is that recursive? Let's know about that. Uh, Recursive it is also programming technique, and it is a process in which the function we have defined it calls itself. Means suppose if you have a function sum, then that sum calls itself directly or indirectly to solve a problem by breaking it into smaller subproblems. So that's called recursion. We can also say it's a technique of solving problem by dividing into smaller and similar problems until a base case is reached. In recursion, we have mainly two components here. The first is base and second is a recursion. When you talk about the base, then base simply says that uh, that condition which we have to put to stop the recursion. Means it's a recursion stopping point. We must put it that stopping point in the function. Otherwise, the program it will go infinitely. So that stopping point is called base case. Next is a recursive case. If the condition is not matched, if the condition is not true, it is false. Then what happens? Recursive case it goes in execution. So recursive case it is a logic to break down the problem into smaller problems and make a more recursive calls to solve the problem. Each recursive call solves a smaller subproblem, bringing the solution closer to the base case. It goes on executing means self-calling we can say until we get the base case. Means as we get base case, the program stops and we get the output. So it was over the base and the recursive. Now recursive function is needed. Why? There are many reasons. First is to simplify the problem, handling the data structures like list, queue, backtracking the problems. Backtracking means exploring all the possible solutions and discarding the invalid ones. If we like the particular one, then we have to use it. If we don't like, then we have to discard that. Like n queens, Sudoku, and many others. Mathematical and algorithmic elegance, for that also recursion can be used. Now, what is the structure of recursion? Obviously, I just said that recursion, when you talk about it, contains two major components: the base case, that is called stopping point, and next is the recursive case, that is execution point. How we write that? So we write in return type. We may use void or int or float, doesn't matter the name of function and the parameter. Inside that we put the condition, that is called base condition. Means if the condition is true, thus we have to stop it, return a specific value or perform a specific action. Otherwise, we have to go on executing, else part is here. So here is the base case. If the base condition is true, do something there, we may stop there. Mostly we use base case to stop the uh, self-calling. If the condition is not true, then else part it goes here. We write the statement here. So that's called recursive case. So base case and recursive case we use in this way. So here is a recursive case, means execution we want to perform there, and this is base case, means we want to stop the condition we want to use to stop the further execution. So this is how we write that. So one example is written here. We'll see this example how it works. Before that, we want to see one example, and using that void return. Let's open the compiler here. So you can join me if you have not joined. You can share with your friends. Let's open a file. Let's make a function. Let's pass the parameter here. First, let's pass the parameter here. Let's give int I equals to 1. Let's pass this series I, return 0. Let's use the function definition. So int k. Now let's put the first base part. Suppose we want to print 1 to 10, means as the value k it becomes more than 10, then what we have to do there, we have to stop it. So return else else what we have to put here, recursive case we have to put here. So what we want to print that, so let's put printf. So d, so let's put space here and then k, and we have to use recursive case, means we have to call this function again and again. So what we need there, we need to put the same function here, series, and we have to change the value of k by 1. So k plus 1. So here is, that's all. Now let's save it. Here is recursive function. Now let's run it. If there is a bug, we'll remove it. We can see here we are getting 1 2 3 4 5 6 7 8 9 10. How it works, it's very simple. First, we have declared a function and that return type is void. We are passing one parameter that is called argument from here while calling. So one is being passed to k. Now this is the base case. Stopping point. Base case is stopping point, else this part is a recursive case. Means now, so initially when the value of k is 1, the condition is not being true, so It don't stop that, it passes to else. In else, what is happening there? K is getting printed. Next, the value is K is changed by 1. So series here, it is the same name of function as we have used here, series. So what happens? It calls this function. It calls this function, the value of K changes. Next time it becomes 2. Again, we can see here, condition not true. It is get printing and just calling is done from here. Next time, K becomes 3. It goes here. Again, K becomes 3. It comes here. So condition is not true. It is printed from here. The value changed. Again, it is called from here. And after that, value K becomes 4. Again, it comes here. Condition is not true. It does not satisfy. So it passes to else part. So here again, it is getting printed. And that printed value is passed to this function. Okay. Next time what happens? Again, this function is calling. This function is calling means it calls this part with different value of K, that is maybe 4 5. Again it comes down and so on, means so moving down and just moving up. In this way the recursive works. At last we'll get the output 1 2 3 4 5 6 7 8 9 and 10. So this is called recursive concept, to print the value of series 1 2 3 4 5 6 7 8 9 and 10. Now this was the first example, a very simple example we took here. I think you answered this one. Now let's take another example. I'm going to save same program as factorial value using recursion. Save it. Let's change the function here. Let's put here factorial. We have to return the value, so int factorial. Now we are going to pass a value from here. Let's put n here. Let's put print here. First let's go for print input. So enter our number, scanner d and now we have to pass this and to the definition part. The factorial value is equals to b. Next is here and so name of function is factorial. So let's put n here. So this part finished. We can say here, this part we have finished. Now let's go for this part. Calling, we have already done that. Now let's do some logic here. Okay. Now first we have to, let's give a variable here and let's put another number. Now we have to first think that actually what could be the best case, means a stopping point. Now if the k is equals to 0, if the k is 0, means so what we have to do there, we have to put the returning part, that is 1. We cannot put 0, so we have to put return 1. Else what we have to do there, so printing is not asked, so we have to go for multiplication. So let's put here return number. Since we have to go for multiplication, let's put asterisk. And since we need to use the recursive, and that name of function is factorial. And the factorial means if the number is 4, then multiply all the numbers 4 into 3 into 2 into 1, we have to put it here. So we have to decrease the number like by 1, so we need to put here number minus 1. This is how it works. So this is the recursive case and this is the base case, stopping point. Now when the number we supply here, that comes here, and if 5 is here, then 5 into factorial means it is further broken into again 4 into 3 into 2 into 1, and after winding up, what happens, it multiplies all those numbers and gives the final result from here. Let's save it, run it. Sorry, here is k, we have to put number. Next is let's put 4, so we can see the output is 4. That's 24. Now how this actually works, let's go for the explanation. For that, here is the explanation stepwise. Let's go for this one. The first is a division of this problem I have written here. So initial call. So first, when we give a number equals to 4, it is called. Since n is not 0, it goes to recursive case. That's 4 into factorial into 3. Okay, means 4 into factorial 3, and 3 is again it is for factorial 3, it calls the next part factorial 3, that is second call for factorial 3. So it becomes we can say again that n is not 0, so it goes to next call, that is next call is a factorial 2. Factorial 2 is called. Here n is again not 0, so it goes into the next recursive case, means next call, that is factorial into 1. Factorial 1, it is called factorial 1 while calling again n is not 0, so it goes for the next recursive case, next call, that is factorial into 0. Now 0 as it is, what happens, so this condition matches, means it returns 1. Now it returns back to the original value, and that is 0, and base case reached means it met the condition, so 0 it returns 1. So now this 1 is supplied to the previous call, like from 0 we got to 1, 1 is supplied to factorial 1, so it gives us 1 into 1 1, so that is supplied to factorial 2. So factorial 2, it gives us 2 into 1 2, and that is supplied to factorial 3. So 3 again gives us 3 into 2 6, it is supplied to factorial 4, and it gives us as last as 24, and 24 we get output from the this calling part, means it calls only once, not repeatedly. It gives us the final value, that final value we get from this part. Visualization we can do in this way, like suppose we are giving number equals to 4, so n is here, so here is n minus 1 3. Now this part is further broken into, so 4 already here, now this factorial 3, it is broken into 3 into, so that 3 it comes here before factorial. Now this factorial n minus 1, that is 2 3 minus 1 2 we get here. Now 3 remains here, 4 also remains here without any sense. Now this factorial 2, it is further broken here, so 4 3. Now 2 comes forward, 2 is here into factorial 2 minus 1 1. So this one is further broken here, so 4 into 3 into 2, they are in same position, they are not changing, so we get here 1 1 comes here in front of factorial, 1 minus 1, it becomes 0. Now the base case is reached. As the base case reaches, what happens? It gives us 1. From this program, it gives us 1. Now after that, what happens? This one, it reverses back, means 1 into 1, 1, and it again 1 into 2, 2, 2 into 3, 6, 6 into 4, 24. So at last we get the 24. So this is how recursive function works. So obviously, actually, this is uh, not a normal function. Here we have to think the main part is the base case, that is the stopping point. What conditions should we put here so that it would stop there? And this is recursive part. So both the parts are important. We have to think on them before we writing the uh, recursive function in our program. I hope you also about this one. If you have any questions regarding this, just you can ask me. You can join me, you can subscribe the channel, you can share with your friends, and if you have any comments, if you have any doubts, you can ask me. I hope you like the video. uh, if you have any confusion, just put in the comment box. If you don't have, fine. You want to discuss with me on particular topic, just give me the topic. Thank you. This was for today. Tomorrow we'll be discussing about the new topic of structure and the union. Till then, take care and thank you.